last half an hour to 40 minutes. Let me give my quick introduction. Myself, Dr. Sanjay Bankapur, and I have joined as assistant professor in the Department of Computer Science and Engineering in last year, August. So it's been 4.5 months in NIT Puducherry. Before that, I completed my BTech in 2005 and worked for 6 years in IT industry, various reputed industries, companies. And then I completed my MTech from IIIT Hyderabad, Computer Science Department. I gave GATE, got 98.12 percentile and joined IIIT Hyderabad, completed my master's. And then again I worked for 1 year in industry, joined MIT Manipal as an assistant professor for a semester. Then again I moved to pursuing my PhD from NIT K Surathkal, NIT Karnataka Surathkal. So for 5 years, my core strengths, my area of interest, machine learning, data mining, and algorithms and programming, coding, etc. So I will be handling Python programming fundamentals for you all. So hope this will be a good roller coaster course for both of us, not just for me. I know Python programming, but I have not taken Python programming as a subject to teach students. And now I got a bunch of students from non-CS background, so it's a very challenging for me and I am very much looking forward to it. Alright. So again, one more thing in these questions, whenever you got doubt, list out all the questions. Also, I want continuous, inputs, like whether I'm going a bit fast or a bit slow. I usually consider the majority. So I will be having some quick questionnaires, like it happened today, from 5 to 10 minutes questionnaire, so that I will adjust the pace of teaching and pace of teaching, especially going forward. All right, so let's start the unit 1. These are the topics will be covered as part of the unit 1, the way of programming, and followed by Python and its history. All right, the way of the program. Why the concept, the way of the program is coming into the picture right now. We'll see. For any engineer, it's not just computer science engineer, any engineer, the important skill to have, to possess, to exhibit is problem solving. And majority of the students are from electrical and few bunch of folks from mechanical also. So we all know, like, having a problem and there are a bunch of solutions are also available for the same problem. So it's not just providing a solution, but also providing a better solution. That's why the bunch of solutions are available for every problem. There can be a multiple ways to tackle that problem and multiple ways to achieve or to solve the problem, right? So I'm still not have come to probably program or complex problem can be addressed through computer. Through computer, but problem solution get tired, like to after some probably we need a break, but computer doesn't, until unless there is a good resources. When I say resources, electricity, power backup, and there is enough RAM to run the things, there's a chance that the code might take off. Program that, we need to program appropriately. As it turns out, the process of learning to program, is an excellent opportunity to practice problem solving skill. That's the way the topic, the programming languages, I can see that majority of this kind of similar to what they answered today, right? The answer, the reply will be slightly different. It won't be an exact. But however, computer, if you programmed and it works fine, then it will work forever and consistently without any tiredness there. So now, what is a program? I talked about complex problems, and when I say if I program it properly, so we'll see what is program in general. A program is a sequence of instructions that specifies how to perform a computation. Computation means computer does computation. What is that computation? It's a execution of sequence of instructions, and each instructions will be making some sense. All right, and these computations or instructions can be categorized into mathematical instructions, where you're trying to solve some system equations or finding some roots, polynomial math. In math, there are so many formulas to implement and stuff like that. And also, when I talk about computation, there are something called symbolic computations, such as searching and replacing text in a document. So, document processing. When I talk about computation, even graphical processing is also part of computation. Just like displaying an image, playing a video game, playing a video, playing a movie, right? In computer, it's a set of instructions will be happening at operating system level and displayed on monitor. These are also considered as computations. What all the things, instructions are getting executed at CPU level. You all understand what is CPU, right? Central Processing Unit, CPU, where it takes a CPU cycles to run. These are all computations. So a program is a sequence of instruction that specifies how to perform a computation. In Python, there are set of rules we need to follow to perform these computations. We are now more interested in how to perform a computation. This whole course will be the whole course will just highlights exhibits about how to perform computation, what all ways we have to do such thing, wonderful things. So we'll try to learn in detail, or probably if not in detail, at least at good level, not at, if not at the complete depth level, and what all options we got and how we can best we can make use of it. All right, so I want all the students to think how computer will treat, how computer will do. Yes, I am the programmer. I will be giving this instruction, how it will work, how it will take, and how it will process, how it will give output. All right. This element of curiosity, I request everyone to have. Even if they are not having, it is okay. How to perform a computation is what all we going to explore in this course. So in general, a program will be having these probably 4 to 5 concepts consistently. One is input. First of all, before going in this detail, till now, the way I am, going with the flow, if the pace is okay, students, and the language and the content, we're able to understand? Yes. All right. Good. Okay. So coming to input, program might require input to process, or sometime it doesn't. All right. So input is the data which takes from keyboard or a file or through network or some other devices, and that data will be used inside the program, and it does the computation on that data. Then output, whatever the computation is being done, the final result will be displayed on screen, or probably we'll try to save that result. If it is too lengthy result, instead of displaying on screen, we'll try to save in file, and or probably we'll send across to the network somewhere, through via internet and things like that. And every program probably will be having a math. Math is performs basic mathematical operations like addition, multiplication, subtraction, and many other, not just basic, majority of the arithmetic operations. Conditional executions. Check for certain conditions and run the appropriate code. Means selective structural code. It will select based on condition. Is it going to rain? If rain, then carry an umbrella. If it is going to rain today, if no, then no need, right? Such conditions, based on that, some necessary actions will be getting executed or taken care. Such are like conditional executions. And repetitions. Perform some actions repeatedly using with some variation. If I want to do a calculation, for example, I have a formula, I want to do a calculation for every natural number, right? The formula is the same. The only thing is the input, that natural number n value is keep on changing, starts with 1, 2, 3 and so on till it reaches 100. So I have to do a 100 time calculation. Very tedious, right? If I program it, just have to do a repetition, only changing that n value, something like that. Very simple, easy to visualize, right? Every program which we are probably in your first semester or second semester being used, no matter how complicated it was, is always made up of that look pretty much simple. The set of instructions, the program is always a collection of set of instructions. If I look at any program in a one go, if it is like 100 lines or some 200 lines, it looks complex. But when we go line by line, why it is so and things like that, it looks very simple. It is just a set of instructions. So the overall point here is the programming language. When we make use of programming language to solve a problem, or probably a bigger problem or a complex problem, is breaking that problem, large problem into simple tasks, smaller subtasks, until it becomes very primitive or very atomic, and then collectively executing all those instructions one by one to finally get the result for that given problem. So the idea is instructions. Instructions are probably subtask. Subtask logically instructions with respect to computer. About Python and its use, we have a couple of minutes more, so quickly I'll take up this slide. Python, we are learning in this whole course. We'll be exploring more about Python as a programming language. We'll try to learn all the fundamentals of it, how to make use of the available concepts for our necessary programming skills, or probably necessary problem solving skills. Python is an interpreted, high-level, general-purpose programming language. So there are multiple features, like I have highlighted in brown, indicating it's a special meaning has been, it has a special meaning. Interpreted, it has a special meaning, means majority of the programming language are either compiled one or interpreted one. So Python is interpreted one. C language is a compiled one. It will take the whole program, it will compile from start to end. The whole program is in high level language. Some English statements we write, we'll do if condition, else condition, such things. Even though it is syntax looks very geeky way, but it is still few English words here and there, right? So it's a high level language. Even Python is a high level language. Will be converted into machine level language. Our computer will only understand zeros or one, binary language. So this conversion, the translation from high level to low level, is either done by a compiler or interpreter. So Python has an interpreter. It interprets line by line. It reads a line, it converts it and executes it, gives the output. That's how it is interpreted. And it's a high level language. As I said, it's a high level language. General purpose programming language means this language is being adopted by various domains, not just in few fields, in across fields. Many of the students have said that this programming language helps me in so that domain, this domain, right? Yes, in electrical, so many, again, verticals are there. Now, usually programming language started with batch jobs, some document processing, some telecom, phone related, communication protocols, things like that. And few of the language are explicitly for, communicating from one phone to other, or probably one place to the other place, telecommunication. But this language is general purpose. It can be used in bank, it can be used in telecommunication, it can be used in web browser, etc. and so on. Okay, that's why it is general purpose. All right, it's already 2:20. I will stop for today's class. I hope Bharat has taken the attendance. I will get back to you on tomorrow, same timings. We have 3 classes in a week, 1:30 to 2:20 on Monday, Tuesday, same timing. Wednesday it is, I think 3:30 to 4:20, I guess. I'm not very sure, but yeah, I'll be sending those details through WhatsApp. Okay, students, thanks for joining, and we'll meet tomorrow's class.